de la présentation. Bienvenue, welcome back here in the main amphitheater. I hope you had a great morning, and I'm sure that Guillaume's keynote was perfect. And yeah, as Nicholas already told you, we'll finally start with the on-site challenges. And for that, we'll present you now the 5 challenges, and then we have a smart voting mechanism where you can over lunch express your preferences, and then the tool will automatically give you the best possible preferences according to that. We have all challenges filled, and all teams are more or less the same size. So yeah, Christian set up the tool, and he will quickly explain it to you.
Yeah, thanks, Marc-Oliver. So I will send around a mail soon, which will look like this one here. We have the 6 topics here of our challenges, and it's your task to copy that part between the dashes, fill out your priorities. So here's, for every challenge at the moment, there is a 1. Just fill it out, fitting to your preferences. So 1 is the highest priority, and then you can just go up to any number, like you can do it from 1 to 6 would be easiest. It's also possible to put a same priority to 2 or more topics. So if you can't decide, then you can set the 1 to multiple topics, or you can just leave it like that. Then it's like you don't have any preference there. Then copy this part into a file, storing it with the file name, last name, and given name, and upload it to the website where you also uploaded the PhD posters. The link will also be included within the mail.
So who understood how it works? Okay, 3 people, very good. So
perfect. So why?
Maybe I say it also once again. So your task is create an empty text file.
Yeah.
That is called last name underscore given name.
Like.
Okay, first step. Second step, copy and paste this part with topics from the email Christian will send in a second. Copy it into the text file. And third step, if you are indifferent between all topics, you can leave it as it is, and you will get a topic assigned. If you want to give preferences to the topics, you have to change the numbers in front of each topic, and the topic that you are most interested in would be the 1, and then the second most interested, the 2, the third most interested, the 3, and like that you can express your preferences. You could probably even delete some lines or not.
Better not. So just
leave all lines, and if you have topics that you're absolutely not interested, just put them a 7, and then it's clear that you're not interested in those topics. Okay, how many people understood how it works? For those for whom it's not clear yet, which questions do you have? Okay, so and the important task is over lunch. So after our presentation, you have to do this. Otherwise, you will be assigned to a random challenge, which is also fine for us, but maybe you have some preferences.
So yeah, exactly. So if you don't submit a preference, we will just take it as it is. So every challenge will weight it equally. And if you have any questions, You can also respond or write to my mail, and yeah, tell me your question.
Or you can also just walk to Christian and talk to him. It's also possible.
I mean,
so there's a question. Maybe just go there with a microphone so that everybody hears it.
Thank you. I'm just asking, have we, do we send the email before lunch or after lunch?
Okay, that's also a very good question, because the idea is that you do not even send an email, but you use the same tool that we used for the posters, and you just upload your text file there. Christian will, after lunch, so at which time will you do it? At now it's 12, so at 1:30 maybe.
Yeah, probably.
Or we can even do it live here in the end, and then we'll announce after lunch. We'll reconvene here again, and then we'll announce who's in which team. And that means you can do it after lunch. No worries about that. But like at the moment we are here, you should then send it.
Yes, so yes, as Laurent is saying, the idea is that you can also use the lunchtime to discuss with the challenge manager, so you can know more, you can have more details, and then it's after lunch that you have to upload this file. You know, like before the end of the lunch, between the end of the lunch and the starting of the keynote.
And the good thing is there are no losers, because all challenges are super exciting, and therefore you cannot do a wrong vote, but you can just put like which are your preferences. And today we also have a camera kit, and now we see that it's working very good. And if you want to do it another day, feel free also to do it. We especially put it because some of the challenges will be presented outside, and therefore we also want to stream that. Good. So now it's clear how it works. Good. So this is how it works, and now to remind you again on all the challenges that we already presented, and as you see that there are lots of challenges that we did not present because they emerged to us at least today, which is great. So it's very dynamic, and so what I will do now is, as I was not aware of the numbering, I will present to you the C1 and the C6, and then Laurent will present something. I don't know which one he will present, but he will tell you. And for the other ones, it will be outside. So then afterwards we go outside, and there you saw already that there's a lot of stuff installed from the Camp OSV and from the SHIC probably, and therefore, yeah, we'll go outside, and there you hear more about it. So, but now let's start with the first topic. I already talked to you about it, but I structured it a little bit more. So the first topic. Do you want to present the hardware once again? Okay. So the first topic will be with Christian. So Christian will be the tutor that takes care of it. I'll also be happy to discuss with you, but he will be your main contact point. And so the first one is a hardware-software mashup with reverse engineering. So we have some cheap Chinese IoT devices, which are these lights here. And they are controllable via Bluetooth Low Energy, with a proprietary protocol, and therefore we have to do some reverse engineering. The same stuff for a clock that has a countdown timer, which is helpful for informing speakers, for instance, about the remaining time, or when you present here your PhD challenge. This one is using infrared communication, again with the proprietary protocol, so this is also reverse engineering, even though we know how to reverse engineer both protocols, so don't worry about that, but this will be an interesting part of it. And the challenge will be also disassembling the hardware for looking a little bit inside. We already opened it together with Laurent some days ago, so you can have a look, and then you will create some gateways towards the different devices. You will create some logic, and yeah, so this is this challenge. And one result I want to have afterwards is this speaker. There you see it now. This speaker information system, where we have the remaining time for the speaker, so that when I stand here, I see, okay, I still have 10 minutes, and that the bars I mean, you can think what you want to do with it, so you're totally free with it, so that the bars also indicate it somehow, so that I do not necessarily see only the time, but also maybe some colors. Okay. Are there questions to this challenge? If not, I switch to the next. So here you also see it again. The next challenge, which is the one that is listed last, so the Q6, I guess, this is live data analytics and processing. So we have the live streaming, as you know, and we already have a tool that is automatically taking screenshots. It's already quite cool. But the idea here is to look at live data. In this case, we'll have image data and voice data, and to do live data analytics. Meaning more in detail that you look at the image data and you look at the voice. So you will use natural language processing to understand what is happening. And the goal here is to create a bot or multiple bots that are automatically filling social media channels. So that are creating like Instagram pictures or creating Twitter posts. And this will be very interesting to look at, because it's to contextualize information and to find out how we can automatically create something. More details in the challenge. Okay, good. So these were the two challenges. And this challenge Lars is taken care of. And Erkin will also support both teams in the creation phase, and also later, where you will discuss a bit what you want to do and how you want to continue and so on. Because for the structuring, I would propose you, at least for these challenges, but also probably for the others, to start with making a concept. Where do you want to go? How do you want to distribute the tasks? And then afterwards, start full into it. For the timing, we have time today, and also tomorrow, the full day, interrupted only by the 2 keynotes, and also tomorrow night. Okay, with that, Laurent, I would hand over to you. Yes. You want to present here? Okay, perfect. Okay, I thought the other one. Okay, perfect. Then I hand over to this Laurent, who has printed his slide directly on his t-shirt.
Yeah, so there is too many Laurent, so don't mistake. So we have the last Sexy challenge because it's coding, but it's a way also to participate to the standardization process of a protocol that we described last time, which is called SHIC, for standard static context header compression. And we are here. So the name of the challenge is chicken, because it's a very stupid joke about the acronym. And so we have this t-shirt, and we have also the eggs before the chicken. So what is SHIC, as I said last time, is a compression protocol that allows you to bring IP to very constrained IoT devices. And that's very important because this way you can manage the same way constrained devices and non-constrained devices. So it helps you to have a bigger Internet of Things. And so, as I said also last time, it's a standardization effort that has been done at the IETF. And we have some RFCs that describe the protocol, and we have implementation. And one of these implementation is OpenSHIC, that has been developed during the standardization process. And what we proposed today is to extend this implementation to new protocols. And one of them is BACnet. BACnet is a protocol used in buildings to manage air conditioning and lighting or other stuff. So what we will have to do is to take some BACnet trace and do compression, describe new compression rules for this protocol, and see the complexity if BACnet did well with SHIC compression. And we are sure that it's the case, but we have to prove it. So I will not be here during the lunch, but Ivan will help you too.
So as Laurent said, hey, I'm Ivan. And if you have some questions, we can discuss during the lunch. And then we will see, hopefully we will see many of you on our challenge. Thank you.
Thank you very much. So the three other projects are linked with the camp OSV, you know, this joint event that you saw the hardware outside. So I will let David present his project on the OSV, open source vehicle. And then once he has done it, we can go outside and see the hardware. And he will show you the hardware of his project, and then we will present you the two other projects of the Camp OSV outside. Okay? So David will speak in French, but then you can ask questions in English, or we can discuss, as said, during the lunch for the non-French speaker. Sorry for that.
Thank you. Merci. Bien. Je m'appelle David Levallois, je travaille pour l'ISTIC, qui regroupe l'électronique et l'informatique, pour l'enseignement uniquement, de licence 1 à Master 2, donc je passe beaucoup de temps sur tout ce qui est projet, orienté surtout système embarqué, qui est un peu plus ma spécialité. Vous m'entendez ? Donc la partie système embarqué est très implantée chez nous, l'électronique numérique plutôt. Et donc on a proposé beaucoup de projets depuis pas mal d'années orientés open source, en particulier des cartes que vous pouvez reconnaître qui sont très implantées dans la planète open source avec Arduino, Raspberry. C'est des projets que l'on voit dans beaucoup de projets d'étudiants, puisqu'on procède beaucoup par projet. Tous les ans, les étudiants ont leur propre projet. Donc la robotique, la domotique, et les licences pro système embarqué chez nous sont des filières qui utilisent beaucoup d'objets connectés en fait. Donc là, le jour où l'IETR a acheté l'OSV, on a imaginé implanter des projets qui étaient déjà en particulier de la robotique beaucoup chez nous. Et donc, comme la filière licence pro système embarqué pour l'automobile et le transport était déjà bien ancrée chez nous depuis quelques années, on a proposé aux étudiants de développer des projets autour de l'OSV. Donc on a d'abord commencé à le faire sur table. Alors vous voyez ce genre de carte avec des objets connectés, eh bien on est dans l'électronique modulable, hein, des choses qui sont vues par les étudiants assez simples en travaux pratiques, hein. Un ultrason, un capteur de lumière, voilà. Et on a de l'analogique et du numérique assez simple. Et on a voulu rajouter des éléments qui sont un peu plus complexes. Et pourquoi pas très proche de l'automobile, sur une maquette qui serait plug and play sur le véhicule. Le but était de pouvoir y mettre un projet, et l'OSV à la base était prévu pour que beaucoup de gens y mettent leurs idées sur l'OSV. Donc on met la maquette, on l'enlève et quelqu'un peut mettre autre chose à la place, quoi. Donc là je vais vous parler un peu plus architecture fonctionnelle d'un véhicule. Les véhicules sont faits comme ça, avec des bus de communication. On est dans le bus CAN, qui est très implanté et qui le reste encore aujourd'hui. Donc c'est un bus qui nous permet d'envoyer des données avec un identifiant, et pourquoi pas avec des octets qui veulent dire quelque chose pour, par exemple, allumer des feux ou capter la vitesse du véhicule et des choses comme ça, avec des réseaux qui ont leur fonctionnalité. Et au cœur de tout ça, vous avez un boîtier de servitude intelligent. Alors, je ne sais pas si vous voyez ce que je vois. Voilà. Un boîtier de servitude intelligent qui est un OS, qui est implanté avec un OS temps réel, pour maîtriser le temps, pour maîtriser les données et la quantité de données dans un véhicule. Il faut maîtriser le temps. Alors voilà, je vais vous montrer juste un ou deux exemples. On a des boîtiers et chacun sont comme sur un véhicule actuel avec un calculateur et des données qui sont véhiculées via le bus de communication, le bus CAN. Là, en l'occurrence, on déverrouille notre maquette avec un tag RFID et un relais. Toutes les cartes sont alimentées de cette façon-là. Donc là, d'autres exemples avec des ultrasons pour le boîtier avant et des feux, la même chose pour l'arrière. Voilà. Donc ça, c'est implanté sur le véhicule, ça donne ce genre de choses. Et la maquette est dehors sur table. Et on a imaginé le mettre au point avec les exemples qu'il y a de projets. Alors on est en 2018-2019. Hein. s'inspire de ce qui existe dans l'automobile. Dans l'automobile, vous avez une application sur les nouveaux véhicules, et ce n'est plus un cadran aiguille, un combiné avec des aiguilles, vous avez une application, et le but c'était là, encadré par Ghislain Nouvel qui fait partie de la plateforme Mobi, qui est plus orientée IoT et une nouvelle technologie, c'est d'animer l'application en fonction de ce qui se passe. Avoir un effet de profondeur, avoir des informations qui interagissent avec l'utilisateur. Imaginez que quand vous roulez plus ou moins vite, vous allez avoir votre tableau de bord qui va s'ouvrir devant, enfin l'image du tableau de bord qui va s'ouvrir avec la partie GPS au loin, et quand vous êtes en ville, ça s'approche. Et le but, c'est de récupérer les informations du véhicule et l'afficher sur votre tableau de bord sous forme d'application animée. Donc là, on utilise le langage C# avec le logiciel Unity. Donc le véhicule, la deuxième année, on l'a amené dans nos locaux, et on a, avec les enseignants impliqués dans le projet, là j'ai oublié de les citer, Laurent Lebrisoil, qui est responsable de la plateforme Mobi, responsable de la licence pro au système embarqué pour le transport automobile. Vous voyez là sur votre droite, c'est Damien Hardy, qui est enseignant holistique en informatique. Il enseigne la partie temps réel. Il y a aussi donc Ghislain Nouvel pour la partie IoT. Donc sur le véhicule, ça donne ce genre de choses. Donc vous voyez ici, on a un volant avec, on a possibilité de simuler sur table le fonctionnement de l'OSV, donc ou l'avoir directement sur l'OSV, ou comme c'est le cas dehors là, pouvoir faire comme si on était sur le véhicule réel. Donc là, c'était l'architecture fonctionnelle de l'année dernière. Je vais aller sur celle de cette année. Voilà, on a proposé cette architecture et ça s'approche de plus en plus à ce qu'il y a réellement dans un véhicule. Vous voyez au cœur, vous avez un boîtier de servitude intelligent, et on communique via bus de communication entre un CAN primaire, ici, et un CAN secondaire. Donc là, dans un véhicule, vous avez ce genre d'informations qui sont véhiculées via le boîtier de servitude intelligent. Et vous avez des informations venant de l'OSV qui sont la vitesse, la température, l'angle au volant. Vous avez différentes choses qui passent dans les bus de communication et qui permettent nous de faire fonctionner le véhicule comme un vrai. Donc là, les projets des étudiants qui seront là demain après-midi, on les a invités sur place parce qu'on a déplacé la maquette OSV. Ils viendront, les étudiants de licence pro, travailler sur leur projet. Donc, en l'occurrence, on a un projet qui est proposé pour instrumenter un peu plus le véhicule, pour faire un peu de sécurité et aussi pour faire évoluer l'interface écran, pour voir des choses qui sont en particulier pour l'infotainment, qui sont sur ce qu'on appelle l'écran multimédia. Le vrai terme, c'est l'infotainment. Donc on a ces données-là qui restaient à améliorer sur le projet de cette année. On a eu ces idées-là. Alors il y a aussi un lidar qui a été acheté par un des enseignants. Et ce lidar, il a la particularité de récupérer toutes les informations du véhicule avec la distance qu'il peut y avoir par rapport à un obstacle, et de mettre en alerte le conducteur. Là, l'électronique embarquée, ça représente ça. Donc on a une Raspberry, un OS Raspbian, un shield de CAN, et le lidar envoie l'information au réseau pour ensuite l'afficher par l'intermédiaire d'un écran, de l'interface écran, l'intermédiaire d'une carte ESP32. Voilà. Donc là, il y a un autre projet qui est orienté plutôt temps réel et OBD. Alors l'OBD, c'est pour le diagnostic sur votre véhicule. Quand vous l'amenez au garage, vous mettez la prise diag. Et donc le but, c'était d'associer les informations qu'on peut avoir à récupérer sur l'OBD, et ce qui, pourquoi pas, pourrait être, dans les nouveaux véhicules, ils en parlent de plus en plus, une boîte noire. Donc quelque chose d'assez simple pour récupérer les informations qui auraient pu être un danger imminent, pourquoi pas, et donc qu'est-ce qui s'est passé dans les secondes qui précèdent. Voilà, donc là, pour la partie temps réel, ça fait ce genre de choses sur lesquelles les étudiants travaillent déjà depuis 2 ou 3 semaines. Voilà, alors l'objectif de ce projet-là, qui était orienté camp OSV, c'était d'abord de montrer ce qu'on peut faire avec un véhicule, mais aussi vous suggérer, pourquoi pas, une collaboration avec l'Internet des objets, et en particulier tout ce qui est cybersécurité. De plus en plus, c'est un sujet qui revient dans l'automobile. Et en particulier, alors je vais revenir sur cette partie-là. En fait, vous avez deux cartes qui sont des objets connectés. Vous avez, enfin 3, puisqu'il y a 2 Raspberry qui sont connectés en Wi-Fi ou Bluetooth, et sur lesquels vous pourriez, pourquoi pas, vous connecter et pouvoir envoyer des données sur le véhicule et changer des choses pour interagir de façon pour hacker, pourquoi pas, le véhicule, quoi. Donc là, si vous avez des connaissances en communication Wi-Fi dans les objets connectés et l'Internet des objets, vous pourriez imaginer accéder à la Raspberry à distance ou le SP32 qui fait du Wi-Fi aussi, et venir interagir avec le véhicule. Voilà, c'est une faille qui n'est toujours pas résolue, à mon avis, parce que c'est des sujets qu'on entend régulièrement, en particulier sur l'infotainment, qui est un OS, et souvent c'est du Linux. Si on arrive à se connecter à cet OS-là, on peut hacker le véhicule. Donc c'est des choses qui restent à faire d'un point de vue cybersécurité. Voilà. Merci.
Super, merci beaucoup. And for the English-speaking people, with this project you can revolutionize electric vehicles and also take care of cybersecurity. No, it was much more in detail, of course, but I hope that you could follow a little bit the presentation. Good. And for the other presentations, we'll now go outside. They will be presented there, and then directly afterwards we'll go for lunch. As usual, you can keep your computers here. We'll lock the room, and then after lunch we'll come back here into the amphitheater. Then we'll tell you something about the presentation of the projects on Friday and about how we will continue. So yeah, now let's enjoy the next 3 presentations, and then let's have lunch together, and then see you all again in here, probably 1:30. But as we'll all be all together, we'll also see them.
Okay, I'll give you a quick explanation of this. This is a personal project I built in my garage. It's a recumbent bicycle, so it's got 3 wheels with the pedals inside, so you can pedal, and it has an electric motor in the front wheel. And a simple, it's basically a kit that you can buy online to electrify the vehicle. So, so it's kind of decorated as a Batmobile for fun, and the idea is to see how maybe we can make some IoT to improve the security. So at the moment we've just got flashing lights for turning lights and a front lights, and then rear lights, but nothing is automated, and just got one rear mirror. So the idea for this project, but obviously you can participate and give your ideas as well, but we could perhaps start from a small ESP32 based screen, and maybe work together to make some kind of icons, so we could have to improve the security for the person driving, have different alert icons which could be displayed on the dashboard, which is inside at different critical moments. So that would be one idea for people to get agreement on how we could define simple protocol or architecture, very simple, and we could add some sensors to it. I've got some LiDAR modules, for example, I could bring, and we could maybe use any other kind of sensors connected to this to improve the security of the vehicle. I'm working for Orange in research on mobility, and we're interested in using 5G to improve the security of people traveling in different types of vehicles. So this is kind of a personal project, but it's kind of linked to my actual work. And so all aspects of improving security of moving vehicles are interesting to us. And as Orange, we have obviously 5G, the 5G network, which is being deployed. These are research questions which I'm interested in my research project. And this is a kind of one of the vehicles which we're probably going to see more of, maybe not as a Batmobile, but more vehicles we will see with people traveling to work in different types of vehicles. So yeah, it's a research question that I'm interested in, and maybe for this 3 days, if you're interested to join this workshop with Baptiste, who is also with me, because I won't be here all 3 days because I'm working just across the road. So there you go. That's the propositions to think to get on this or some other simple device for alerting on events to improve the security of the driver. Thank you.
So hello everyone, I'm going to present this workshop. So it's referred to in the document you were given as a BMS, Battery Management System. I'm not only working on this. The elements you can see here are the elements you need to move an electric vehicle, and all this is called powertrain. So here you have a three-phase motor, and to spin this you need a board that's an engine controller, this board, that will convert the DC voltage of the battery to AC voltage. And this board I made is actually derived from open hardware and free software project that you can find online. That's called VESC. And on the other side, you need a battery. So I don't have an actual battery, but we are faking it with this power supply here. And there is also this board that I made that's a battery management system. This is what I'm working on currently, and I've been working on with the composition community for actually quite some years now. And this is a work in progress, so I was inspired by this project to make this one. So this is supposed to be monitored to monitor a 12 cell battery. And there is a lot of things that's not working yet on this. So one of the ideas could be to continue writing the software, making it work. We can talk how to make a good BMS. I already have elements about this. Also, the two boards implement canvas, so we could see how to make the two communicate like they would in a real vehicle. Also, I never tested this motor. I only tried this board with a small motor that I have somewhere, but never mind. So one of the things we could do would be to test this motor. The VSC project comes with configuration software, so yeah, we could see how to make this and this work together. So yeah, this is it. Thank you.
Bah, je sais pas, ça dépend. Yeah, maybe, okay. Maybe we can present a side project. It's about mobility. It's to explore a new way. I don't know if it's a new way because it's with our student, and we just explore a light way to displace things. Maybe you have in your life the possibility to run your car, but it's heavy and it takes a lot of energy. Maybe your bike is cool, but you can't carry a lot of things, and maybe you can't pedal neither. So we explore this scooter, but a cargo scooter, so you can put here some boxes or your child. I made some design. So it's light, so it took not so much. It takes not so much energy, and everybody can carry things because maybe you don't have children yet, and maybe you don't have a family with a lot of grocery to carry every day, but this is the project.
Oui, je ne sais pas si, David, tu voulais rajouter quelque chose par rapport à la plateforme ou pas en français.
Did you understand this platform? Same or not?
Yes, that's French.
Okay. So it's basically some professors at ISTIC have developed this system, which is a way of making a CAN bus like you have in a vehicle, using Arduino, Raspberry Pi, and different simple electronics that you know in your studies. So it's a way of allowing students to interface with the CAN bus and send information and receive information as if it was in a real vehicle, but using open source solutions. And so all the electronics here is using CAN bus interfaces on Arduinos, Raspberry Pis. There's an infotainment screen with a Raspberry Pi, and you have several different buses, internal buses communicating to enable the system to work. Okay. Nice.
What is the objective of the challenge?
To communicate with the OSB and simulate, if you want, to change things, lights, for example, or change information like the angle of the direction, or why not put on the brake to see and replace the good functionality.
Je parle français, mais c'est surtout pour les autres. Mais okay. Si vous voulez répondre pour moi en français, ça ne me pose pas de problème.
If you put on for example, the Raspberry Pi or the ESP, you can change things de la distance, for example, by Wi-Fi.
It means that right now, if you hack the system because it's not well secured, with your smartphone, for example, you can enter the system and then send commands to more or less everything in the car.
Okay.
So one aspect is to study this and to see how the communication network is working between the different elements. and to be able to secure this protocol. Let's go for lunch. Yes. On va mettre dans la salle du fond.
I love this. Do you go to like? I zoom in the desert.
Yeah, but it's good. I just had the idea that we use it for that because it's perfect.
Is this mechanic?
Okay, those who did not submit, do you need some help? If not, we wait for you to do it now. So who did not submit yet? The file? Okay, so it seems everybody in the room submitted. So how many submissions do we have? Well, let's do it as follows. We do the keynote now, because I mean the keynote will not change anything because people cannot start with the challenge. And then we announce the assignment later, then you have 1 hour of time to do that stuff. And if someone is online or on site and did not vote yet, please do so within the next 10 minutes. And then Christian will run the script. And then after the presentation of Pierre, we will announce the winners. And not the winners, but who does which challenge. Okay. And then I will also say a little bit something to how the challenge is in general, what you will present on Friday, and so on. Okay, then welcome back from lunch. I will just skip the slides that we've seen already. Okay, maybe I can quickly put the program. Yes. So yeah, we're in the afternoon now, so we have the keynote by Pierre. And then afterwards, the rest of the afternoon is working on your challenges, and you can stay here until 7, I guess, if you want. So you should stay at least until 6 in order to progress a bit with your challenge, but I will say more about that after the keynote. Okay, so you can switch back. And I will just open Pierre's CV. Okay, so it's a short CV. So, this is the next keynote, and the next keynote speaker is Pierre Begu, and he's from Atlantique, and he will be talking about digital twin and mixed reality for the industry of the future. Pierre is a final year PhD student at the campus Brest of Atlantique, and he's working on digital twin in industry for the training of operators. And also, like with all the other keynote speakers, we have a trailer for the keynote, and Pierre, you can already come over, and I will show the trailer, and then I will hand over to you.
In a context of industrial evolution and the transition to Industry 4.0, the digitalization of industry is necessary. The digital twin is the keystone to this transition by providing a complete digital factory, which enables new ways of simulate and predict behaviors and new ways of training new operators. During my keynote, I will talk about the digital twin, its usage in industry, and its usage in combination with mixed reality. And I will finish by presenting a use case in a French factory.
Perfect. So yeah, I'm already looking forward to it. And as you know, we have the Slido, and I highly encourage you once again to put your questions to the Slido. Even if you're in the audience, then you don't forget them, and you can just put that you're in the audience. And besides that, as I said for the previous talks, for the keynote speaker, it's always good to have some questions, because then you see that the people were attentive and are interested in your topic, and therefore if you could think about one question each, that would be fantastic. So yeah, just be encouraged to also ask questions after the presentation. And that's it. Pierre, I hand over to you, and looking forward to your talk.
Okay. So hello everybody, I'm Pierre Begu and I'm happy to present this keynote about digital twin and mixed reality for the industry of the future, or Industry 4.0. So first a little presentation about me. So I have an engineering degree in informatics and cognitive science, so it was in Bordeaux. And in my last year of PhD, so at IMT Atlantic, and it's a PhD with a company. So I'm working with ELM Leblanc, a boiler manufacturer located in Drancy, so in the north of Paris. And my supervisors are Thierry Duval and Sébastien Kubiquier at IMT Atlantic. So we'll start by a little context about how the manufacture works, how the industry is currently operating. So first, we have the raw materials and parts which are produced. Then they are shipped to the manufacturers. So in our case, ELM Leblanc, which manufactures the boilers, in my case. Then these products are shipped to wholesalers who will sell the product. So right now, everything in the industry works in tense flow, so they tend to not have stock because it's expensive to maintain. The production orders are planned in advance, so usually we have a big order of products planned months in advance, and there's a high inertia to change, so it's very hard to induce change in the factory. And so what happens when we have a raw material shortage or a problem with the shipment? The problem is everything stops and we cannot manufacture anything. Like we can see right now, we have a semiconductor shortage. We have raw material shortage. Right now, it's hard to find wood, to find metal. In case you didn't know, we have a problem with a pandemic. So it's hard to keep manufacturing. And we have new laws that will induce change in industry. For example, in our case, we were manufacturing new boilers working with fuel, and the government passed a new law which forbid these new boilers. So right now we have a whole new assembly line that doesn't work because of this law. So in this complex and volatile world, we need to evolve to make industry evolve. We have to make the industry needs to be more flexible and adaptive and more reactive to change. We need to build smaller quantities but more customized to demand, because now we can't manufacture very big orders. We have to change this kind of things, and we have to modernize the factories by using IoT, big data, mixed reality, and a digital twin. So we'll first explain what is a digital twin. So the first definition was in 2003 by Michael Greaves. So it's a virtual representation of a physical product which contains all the information about the said product. More precisely, because this definition was changed in 2014. So we defined 3 parts for the digital twin. So we have the physical product, which can be a machine, a whole system, or just a screw, for example. We have the virtual product, which is a copy of this product, but virtual. And we have a bidirectional flow of data between these two twins. So to be more precise, we have the physical twin, so single part or complex system. And we have data, and this physical twin will provide data, which can come from internal and external sensor. And this sensor will be part of the physical twin, we have the historical data of the product, like every maintenance which has done on this product, and we can have human input that will send data, for example. And the digital twin, so the virtual product, it's the virtual representation of the physical twin, and it can contain several modules. So, for example, a 3D model, behavioral model, a module to make simulation, and a monitoring module. So the data coming from this digital twin are the simulation and monitoring results, and again can be human input made on the digital twin to be sent on the physical twin. The main application of the digital twin in the industry are product health management or predictive management. It will be used in production to design new products and to train and help maintenance. So the simulation, to make simulation, we'll use behavioral models. For example, what will be the reaction of the product if we exert pressure? We will use data coming from the physical twin and user input, and with these informations, we can have a total simulation of, for example, an assembly line. And we'll use the result of this simulation to predict and adjust the production, or to design new product or process. For example, in these pictures, you can see on the left we have a simulation of this part, and we exert pressure on this part, and we will simulate the displacement on the x-axis to see how the parts will react with the movement of the system, or we can simulate the machining of a part. So we can use the digital twin to monitor a total assembly line, for example, and then again we will use the behavioral models and the data coming from the physical twin. So it will be used to detect problems, to adjust production, or just to know where we are in the production. For example, usually we have production orders for 1 day. For example, we have to produce 60 boilers. With the digital twin and the data coming from the physical twin, we know every time how many boilers we produce. So digital twin can be used to design new products or new systems. So this time we will not make a copy of an existing physical twin. We will start with the digital twin to to create a new product. So again, we will use behavioral models. So we will enter the behavior of the future system. We will simulate, and we will use 3D modeling to know what our physical product will be. So we can design new station, new machines. So in production, we will mainly use the digital twin to monitor the production, but we can use it to update the layout of our production lines virtually to avoid moving every part by hand, etc. And to make optimization of production orders. For example, when we have different products to produce, using the digital twin, we can simulate and test to see which product we will produce first to optimize the product change. So because sometimes we will modify the workstation according to the product to be produced. So digital twin has many use and many good use in the industry, but it has its flaws. So several issues remain. For example, the digital twin generates a lot of data, and this data is difficult to sort and to store, but also to secure. It's hard to visualize and interact with the digital twin naturally. So usually you will have a lot of data, and it's hard to detect to know which data will be useful to you at the moment. And right now it's hard to create a digital twin of an old factory, because it's easier if you have a lot of IoT and big data in your factory. And right now, most of factories in France and I guess the world are not very up to date on these new technologies. So to answer some of these issues, like visualization and interaction, the use of VR or AR, so virtual reality and augmented reality, enables a simpler way to visualize and interact with the digital twin. So to use the example earlier, we can use AR to do the direct monitoring of a machine with the display of information directly on the physical twin, information that we cannot see and cannot know when we are in the production line. We can use the AR to help the training and maintenance of machines. For example, here it's an assembly assistance, so it will display information about the assembly process directly on the workstation. And we can use VR to design and simulate new workstations. For example, in this work, we have the ergonomic assessment of new workstation and the simulation of new workstation. So these use are very interesting, and I will now present a use case we are working on with on the digital twin and the mixed reality. So the Iron Man project, it's a project I'm working on. And so for more context on this project, ELM Leblanc has a seasonal problem. So we on the high season, so it's during winter, we have a workload increase because there's a lot of boilers who are broken, and so we have a lot of order of new boilers. So we have to hire a lot of temporary operators to work on the assembly line. And so we need to train these operators. And right now, the training process lasts between 3 days and 2 weeks, and require the help of an experimented operator to train new operators. So the production line is not working efficiently. And during low season, so we have to, we don't know, the client requests are unpredictable. So we need to be flexible. So we need to be able to the workers need to be able to work on different workstations, because right now they are specialized in one workstation or two, and we need to put them on different workstations. So to answer these problems, we started the Iron Man project. Oh, sorry, we have some French. So it's a project in 3 years with 5 PhD students. So one working on AR acceptance for the workers, so to see if there is problem with wearing an AR headset for a long time. One PhD on workstation modeling, so my part. One PhD on AR training, one in environment and gesture recognition, and one PhD working on 3D simplification. And the goal is to train new operators in real time on the assembly line, to develop the operator's versatility, to increase the flexibility of the production, and finally to prevent work-related disease during training, because sometimes during training the operators are trained with wrong positions, and it develops work-related disease like tendinite. I don't know in English, but some workers develop problems. And so I will speak more about my parts because I work on the digital twin. So the question is, how do we allow operators to be actors in the creation and maintenance of the digital twin of their workstation? So how do we create a digital twin which is loyal to the factory? So how do we create an exact representation of the workstation? which element do we need to display in 3D to be used as spatial anchors. So the goal is to have 3D elements representing the workstation, which will be used to lock informations about these elements in case of modification. I will explain more later. And how do we allow operators to upkeep the digital twin to match the physical twin? Because if we want to train operators using AR, we need to have an exact. We need the instructions to be precise, and so usually operators they like to move the component boxes to simplify their work, and so we need to allow the operators to modify the digital twin to match the physical twin after modifications. So in order to do that, we went on the workstation to to study them and to know which elements are important during work. So this is a workstation from Lem Leblanc. So it's composed like this. So we call that the supermarket. So it's a big shelf containing the component boxes and which contain the components. We have the tools. So I don't know if it's visible here, but they are screwdrivers, electrical screwdrivers. And we have the assembly zone. So here we have an assembly bench, but on some workstation you can have test bench, for example, electrical tests or hydraulic test. And so the parts that are important to copy, so the important parts in the digital twin are these parts, so the component boxes, the tools, and the assembly bench and test bench, because these are the parts which the operator will interact with. So we call them the interaction zone. So these are the parts that are important, and these are the parts that will receive AR informations, AR training informations. So these are the parts that we need to copy and to have 3D model of. Then we created the digital twin models based on the observation on the workstation and the BOM files, so bill of material files. So it's like this. We have the digital twin, so we have all the factory data, so all the information about the components present on the workstation, all the parts, so it's a big database containing everything. And we have the 3D models of the interaction zones. So this is our digital twin. So it's a digital twin, but it's just a part of a digital twin, because we could have simulation models and behavioral models, but we didn't add these parts yet. And it's linked to the real factory by an AR tracker. So right now we use QR codes, but we could use any AR tracker. It's not the most important part. And we added the augmented operator in this model. So an augmented operator is an operator wearing AR headset, and the operator will make the connection and the upkeep and the updates of the digital twin. And so then, to allow the augmented operator to interact with the digital twin and to superimpose the digital twin with the physical twin, we developed WARD, so Workstation AR, Augmented Reality Digital Twin. It's an AR authoring tool. It's connected to the digital twin, and it will allow the operator to superimpose every part with its physical twin. So it will present to him one by one. He will place them. And if the workstation is modified, he can then just displace the digital twin to match the physical twin. Right now it works like that. Our goal is to be able to make the update our goal is that the update will be automatic. So right now we don't track every part, and the goal is to track every part. In the model, every part is tracked, but in real life, it's hard to put AR tracker on every interaction zone because some boxes come from retailers, so we can't put QR codes on everything, and when the box is empty, it's replaced. So we cannot put trackers on everything. And so this digital twin will be used as spatial anchors for AR assembly instructions. So when we update the workstation and the digital twin, the instructions are also updated. So to be more clear, I have a video. We don't need the sound. So right, this is presented like that. So the operator will match the QR code. So you will see a little the holograms will not perfectly match everything like that. The QR code is supposed to be superimposed, but we have it's not perfectly matched because when we record with the headset, we have it's not perfectly matched with the recording, but in real life it is. Okay. So then the application will get every information about the workstation. And then every part, every digital twin will be presented one by one, and we will place it on the physical twin to match everything. I don't know if, okay. And then to test our product, we made an experiment in which we had the operators had 36 digital twin to place, and we compared our tool with the one from Microsoft, so Dynamics guides, and it appeared that our tool is easier and faster to use, and furthermore, our tool is connected to the digital twin, and guides is not. So we had to put every twin. We had to log everything one by one in guides. So we are quite happy with the result. You can see that it's much faster because we want to we tried to make it as simple as possible. So as few information as possible, and we wanted the interactions to be the more natural as possible. Okay, so to conclude, the industry needs to evolve because we need more agility and flexibility and modernization. So the digital twin enables new ways of production and flexibility. So we can simulate and monitor to avoid problems. We can design new products and new assembly lines to adapt faster and easier. And we can, by having production monitoring and simulations, we can make a more personalized production because we can adapt easier. And with the combination with AR or VR, we can train and assist worker more easily, so the training will be faster and in autonomy and directly on the assembly lines. But it's hard to have a consensus on a generic digital twin framework, because right now you can make a generic digital twin, but every operation has its specialties, so it's hard to make something that will adapt to every factory. And it's hard to deploy and maintain a digital twin in all factories, so sometimes you don't have every information necessary. So that's it. Thank you for your attention, and if you have any questions.
Okay, thank you for the talk.
Actually, there are quite some questions.
Okay.
But I would like to start with my question.
Okay.
I was wondering, how about in the practical side? What kind of software are available? Open source or commercial? If we want to play with digital twin, what are the main players there? Are there some GitHub projects that we can create our digital twins and model and such?
Yeah, right now there's no generic framework, no. So every article I saw, every example I saw, there was the digital twin was made from scratch with a homemade framework. So right now it's hard to find something that I have a new company, I have a new product, I want a digital twin of this product, but I have to make it. I cannot use the modules. I cannot grab the module and put it in my digital twin. So right now, yeah, it's hard to find.
Would you say that like there is a gap then? Like that would be nice if there's a framework that we can use some sort of tool set.
It would be nice if we had a simple digital twin base that you could evolve for your needs. And right now we have nothing. So yeah, we created the whole database. We grabbed the whole all the information from the factory. There are bills of materials that are very hard to read when you're not in the field. So we had to adapt and to ask them. And so we deployed in our factory, but we deployed in another one. And right there was some. It wasn't even the same bill of materials, so it wasn't even a standard. So we had to. It was our model was usable, but it was hard to adapt to every factory. So right now, yeah, that's a problem.
We have a lot of questions. This never happened before. Maybe I may need to select, but okay, let's start. Maybe we can even finish in short all of them. First, how do you make the digital twin? Is it like training, like a machine learning model, or is it fitting parameters like more normal simulation?
For the behavioral models, or
it says how can you create a digital twin?
Okay. So it depends what you want to have in which module do you want. Because if you want just like us a representation of the workstation and the assembly lines, you can just have the information stored in a database with like for example, we have assembly line number 1, and in this assembly line we have 12 workstations, which contains 31 component box with these components. And so you can just have this information, and if you have the 3D models, you can use the 3D models to match the physical twin. So in our case, it's very simple, but if you want to make simulations, then you will need all the information how the workstation works. If you have machines, you will need the information about the machines, how many orders you can produce in like 1 hour, how it operates. So you will need. It depends on what you want to do and what you need, and so it can be very simple and it can be very complicated. So it depends on the scope of the digital twin that you want.
How many
maybe let me continue with a follow-up question. So how long did it take to create the digital twins for this setting? So is it hours, is it days, is it weeks?
In our case, it's a simple one because we don't have a lot of information. And in our case, the creation of the database took like 1 month because we also needed a communication between the database and the AR headset. And so because usually in industry it's on the assembly line, usually internet is not very good because it's protected. So we need to go around this. So in our case, 1 month to have the database, so the digital twin data. The 3D models, it depends because we have some, and when we don't, we use just a box to represent a model. But it depends also if you have all the data available of your workstations, because we have this data, but for example, the tools, they are not in the bills of materials. So when you have a screwdriver, it's not in the bills of materials, so you have to check and you have to go on site to see. So this information, it's hard to have. But yeah, I'd say 1 month for the database and like 3 or 4 months for the AR app to have a stable version that works well.
And who was doing the job? Was it you doing the job, external people coming into the company and then creating it, or did you have the experts from the company doing it?
For the database, it was me and the other PhD student working on AR instructions, because we store the instructions. We consider the instructions that the instructions are in the digital twin, because it's technical instruction of the workstation, so we consider that they are part of the digital twin. And so we were 2 working on that. So yeah, it was just the 2 of us, and we made like 3 apps, because we have 1 app to match the digital twin, 1 app to create the instructions, and 1 app to visualize the instructions. So
Okay,
and I'd say everything took us 1 year to make.
Okay, very, very interesting. And could you give some more details about what this digital twin is? So is it a MATLAB model that is running, or is it a Java code, or is it a Python script, and which aspects are modeled within this digital twin?
Yeah, but we have a simple database which contains everything. We are not finished, but we wanted to develop a web interface to send that data in this database. And then we have a web service made in C# communicating between the database and the AR apps. And the apps are made with Unity and MRTK, so the Mixed Reality Toolkit from Microsoft. And we are using HoloLens too.
Okay, nice. Do we have, I can also still has a lot of questions. Do we have some questions from the audience in the room? Yes, there's one question. Christian, could you bring the microphone upstairs?
You have water there as well.
Ah, okay. Thank you.
In case you need more, I can provide you.
Okay, thank you for your presentation. I have a small question. The virtual machine that I don't know if this virtual machine the data collected by this virtual machine depend on the sensor that contain the physical machine. I don't know if you construct the virtual machine depending on the physical functionality of the physical machine. And after collecting all the data, how do you? What is the decision that is taken with the AI model to? I don't know to continue the work, your workflow. Okay.
So you wonder how do we make the digital machine with using the data from the. Because okay, so maybe I wasn't clear. So the definition of the digital twin, you have the physical and the digital, and there are data coming from both of them. Which will so the data will come from both of the twins, and so the data coming from the physical twin will be used in the simulation models, or we will use them to. For example, if you have to know what is the pressure in an oil tank, for example, and so you will use the data coming from the sensor. You will get it in your virtual, your digital twin. And if you need to, maybe you need to know if you can add some oil or you can remove, and so you will simulate in the digital twin what happens if you put some more oil, and you will know the level, your internal pressure. You will use the data from this one, and with the behavioral model you have, you know that if you have the pressure, this oil level and pressure, if you add oil, you know it will explode, for example. So you use the information that you have and the information that you know from the specificities of your physical twin, and you will use them to simulate and to try and to try again to see what you can do.
Okay.
Is that
It's right.
okay?
It's right. It's right. Okay. Thank you.
Any other questions from the audience? Mike is coming. Thank you.
Hello. Thanks for the presentation. I didn't see when you show the video of the IR example. Did you track the hand movement by a controller? Or did you use something basic?
No, yeah, it's in the HoloLens 2 you have a hand tracking module, and so it will track your hand and your fingers, and you can interact with the 3D elements naturally. So you can push buttons, and you can grab 3D models and move them, and you can resize them with using two hands. So we use this technique because it's easier to apprehend this manipulation for operators that never used AR headsets. And that's why it's in our experimentation, we saw that it's easier. Our tool is easier to use than Microsoft's because they use the distant interaction. So they use a raycast from your palm to the 3D models, and then you have to pinch and you grab it from a distance. And so using it, just grabbing directly, it's easier for operators.
Okay.
And so that's what we used. It's from the HoloLens 2. But if we had to use a controller, we couldn't use it in a factory environment because when you give them sensitive elements, usually they are broken in like very fast. They tried to give them tablets, but at first they use it with their finger, then it's with the screwdriver. So you have to be careful. That's why just having your two hands, it's easier.
And could you track the data of the hand move for the future? Maybe train robotic arms to do some of the easiest tasks.
You could track and to train an AI to reproduce the arms. It could be a possibilities, and we have a PhD student working on gesture recognition. So they will use to. For now, it's to validate. For example, if the operators did the task correctly, to switch to the next task. But in the future, you can have a lot of use of this tracking and this learning from your movement.
Okay, thanks again.
Any other questions? While we are thinking, let's pick up from the Slido. How many digital twins have you implemented or are you using in factories?
What?
How many digital twins have you implemented or are you using in the digital factories?
I'm not sure.
Maybe an estimation. I just clicked it, answered, it's vanished.
Okay, I'm not sure I understood the question. How many digital twins do we use?
Or are you using in the factory or have you implemented for the factory?
Yeah, okay. So it depends on the workstations, because when you say digital twin, you can consider if you have the whole factory in your database and you have the whole model of the factory, you can consider it like one digital twin. But I like to consider each interaction zone as its own digital twin because each one is represented and we have the position. So it depends on the workstation. For example, the workstation I made the tests on is composed of like 36 component box, and I represent also the workbench. So we have 37 digital twin on this workstation. So if we implemented the whole factory, we would have a lot. I cannot say, yes. But it depends on what you consider your digital twin. If you consider each part individually, you have a lot. if you consider the factory as one digital twin composed of a sub-digital twin, you have one big digital twin. It's as you see it.
Let's pick this one. How expensive is a digital twin, and what is the benefit for the customers? Amount of cost savings, for example, maintenance cost.
Expensive, it depends. But it's you have the human cost, like for example, the paying the engineers and the PhD student. I don't know how you want to implement it. The benefits for the customer depends on what you want to do. If you want to be able to simulate the production line to make sure everything works, or to monitor, it depends on what's the use you have for a digital twin. So the benefits, there are lots. You have, for example, if you have to design new production lines, you can do it virtually, and it will take a lot less time. So you would have your new production line way faster, and it will be less human cost, because you won't have to move every part. Because in our factory, that's what they did, because we didn't have the digital twin ready, but they made a whole new production line by hand. So they had like big carton box, and they were like, okay, so this would be workstation number 1. Okay, this is the dimension. Oh, okay. Oh no, because we have to put the test bench here. So and doing it virtually with everyone who's connected, like, okay, now we can move it here. That would be way faster. So you could save like 1 month of work. So the benefits, there are lots. It's just hard to imagine when you never tried and never tested one.
How are the physical and digital twins connected? How is the change in the digital twin replicated on the physical one?
Okay, so right now they are connected with an AR tracker, but usually in our case we connected them with AR. So the AR tracker was the connection. The change on the digital twin are not replicated automatically, because we don't have a connected production line.
Yes.
But if you have a production line full of IoT and, for example, automatic with automats, etc., you could make change on your digital twin that would be replicated directly on the physical twin if you use IoT. In our case, we have like 0 IoT in our factory, so we cannot replicate directly change from the digital twin to the physical twin. But if you have like a machine that's connected by IoT, or I don't know, internet, anything connecting the two, you could like say, or you would change the pressure on this bolt, etc., to make these new things, and the change would be like almost instant. It depends on what you have at your disposal in terms of connectivity between your physical twin and your digital twin.
Are there digital twins of the whole product lifecycle management of a product or system at Elm, from design to production, to use it in the field process? This one I asked.
Okay, yeah, in our case, we don't have the whole product management, the whole product life management, because it's an old factory, so a lot of things are on paper or in old softwares, so we don't have a lot of things. But we do have the data, like when a boiler is made, it's scanned on every workstation. When they make their technical work on a boiler, they have little code bars, and they scan, so we know how much where the boiler is on the workstation, and we also know the result of the test. For example, the hydraulic test and electrical test. We know the result of this boiler. So this is the product health management. This the only information that we have. We also know where it will be sent, but we don't have the whole thing, the whole digital twin of the boiler. We just have a few information on this.
Yes.
It's still it's still a new approach of industry, so it's hard to make change, because we gave them an AR training app, and they're still not using it, even if they have a lot of errors on the new production line. So there's a high inertia to change, and so it's hard to make them use the digital twin and the new technologies.
Okay, let's ask one more maybe. There's a last question, not to exhaust you. So I actually highlighted an article for maybe also the audience. I don't know who put that. You can take a look at it, this article. The question I wanted to ask among the remaining ones is, how do users respond? Do they like it?
So we had two types of users in my tests. We had the production line chief. So they were like, okay, it's easy to use, okay, but they didn't know why they were doing this. So we explained to them, but it was hard for them to see the big picture. And we had the methods engineers, so the ones who designed the production line. And so they were like, oh yeah, that's good. Oh, we could use it for that. You could use it. Oh, it's wow. Oh. So they were a lot more excited. But yeah, usually the operators, they didn't know what the digital twin was and why did we work on that. But the training tool, they were a lot more excited for this one, because they could see what was the use. And so we had to say them, yeah, but this is the first part of the training tool, so you have to represent the workstation in order to attach the instructions. So when you move the workstation, when you change the boiler model, you just have to change the thing, and then yeah, you can have your instructions. They were like, ah, okay. So they were okay. They were excited to use new technology, but it's more on the management on top, like the production chief. He never tried, and they didn't want to change things, so yeah, it's hard to make them accept change.
Okay, I would say that's all for the questions. We thank you. Thanks for answering also quite a lot lot of questions.
Perfect.
No
yeah.
problem.
So then
Thank
also
you,
big
everyone.
applause for you, Pierre. I enjoyed it a lot, and also you get the speaker present with lots of nice ingredients. Very good.
Thank you.
So now, I wanted to show the results of the voting. I'll just do so. Ken, could you switch to 3? 3. 3. Thanks. Good. So for the challenges, what I would do next, once you know which challenge you're working on, I would spend at least 1 hour in discussing a bit what you want to do, what you want to achieve, and so on. With the challenges, as I said, you will have time today. Let me just, yeah. So you'll have time today until 6, or if you want to work longer, you can also work longer. And then you will have tomorrow the entire day. We'll start off with the keynote tomorrow morning by the OSV camp. And then you will work in the morning until we go to lunch. After lunch, we have a fireside talk by Guillaume, also from the OSV camp, about open source software. And then you can work also until the evening, and then in the evening we'll have some pizza here, and you can continue working, and also start preparing your presentations. And on Friday, we have a pitch session where you present the results of your challenge, so what you achieved. For that one, it will be interesting to also look a little bit at what is already existing today. How did you advance that? Where did you end up? And more details we'll give you tomorrow. And we'll also give you a template for the presentation. And that means today really think of, okay, what do you want to do? What would be cool as achievement? What is realistic to achieve within the given time? And then start already implementing, hacking, and so on. Are there questions regarding the challenge? Okay, if not, then I welcome Christian on stage for announcing the assignment, and I created it in the way that it reveals challenge by challenge. So it's maximum tension.
Perfect. Okay, yeah, then let's start. So finally, 12 of you submitted their preferences, and the first will be... the hardware-software mashup, it will be done by Shafiq Ahmed and Abdelhamid Gara. The next will be Challenge 2, the chicken challenge, which will be done by Marcos Birgason and Juan Sebastian Molina. Then C3, the battery management system. Okay. Wait, it's not the... No.
So sorry for that. Let's just redo it, because my computer lost connection actually. What's up?
Das sind nur die Namenliste.
Okay.
Okay, ja, jetzt ist das. Aber jetzt wahrscheinlich wieder als ein Block, oder?
Nein.
Also, okay. Ja.
So we remix.
Okay, let's start from the beginning. Sorry. Okay, now let's have the final results for C1, the hardware-software mashup, which will be done by Julius Bünger and Ahmed Shafiq. Then the C2, the chicken challenge, will be done by Marcus Birgason and Victor Guilman. Then C3 will be done by Iba Meri and Sylvain Takugang. C4 will be done by Laila Mokhtar and Juan Sebastian Molina. C5, the OSV, will be done by Dairo Deruk and Alexis Duhamel. And finally, C6, the live data analytics and preprocessing, will be done by Baptiste Bouchy and Abdelhamid Gara. You're what?
Some people are not on the list here, and some people
that submitted?
not here, but it's in the list. Yes. For example, Leila is not here, and I'm not in the list here.
Yeah, but Leila, she's remotely participating. So Leila will be participating, but if you submitted your vote and you're not on the list, then something strange happened.
Okay, yeah, let me maybe clarify what happened, but usually so you did upload
all good things are 3, so we'll have a look. Chris, maybe just look over the on the list if you have them. And besides that, the next step is that you approach those that are the heads of the challenges. So in case of the 2 that come from my group, here you would have Christian and here would have Lars. So Christian is the one with the red shirt and Lars is the one that is in the back with the videos. Do you want to redistribute or you just add them to the topics? Because in the end we have now 2 people areas, so maybe it had like an overflow in the sense that there were like some people that were not distributed because there were no teams left. So you could just look what was their first preference and then we add them to that team.
Okay. I saw the problem. So it was submitted as PDF.
Okay.
So, which was then like usually the PDFs were the PhD
Okay, but then look where we add them.
Yeah.
And update the list and send it to me, then we add them.
Yeah, okay.
Okay, so those of you who submitted and were not distributed, just go to Christian. He will tell you in which challenge you are. And the others, just visit those that are managing your challenge and start discussing with them. Whenever you have questions, just approach us. And yeah, there's a question. Yes, if someone wants to change, so yeah. But also go to Christian if you want to change, and then okay, then have fun with the challenges.